Digital video is the electronic representation of audio/visual content in encoded binary data, zeros and ones. Digital video comprises a series of digital images displayed in rapid succession at varying FPS, frames per second. Creating a digital video involves capturing light through a camera's sensor, which is then converted into electrical signals. These signals are subsequently transformed into digital data using an analog-to-digital converter, ADC. This digital data is typically large in volume, especially for high-definition content, necessitating the use of compression and encoding techniques to reduce file sizes for practical storage and transmission. Digital video was first introduced with the invention of the first-ever DVR, digital video recorder, by Ampex in 1977. However, the digital form did not gain widespread adoption until the early 1990s after the invention of the world's first all-digital format, Sony D1, in 1986. Compression and encoding are vital in digital video technology. They reduce the file size while striving to maintain quality. Common compression methods include lossy compression, which reduces file size by eliminating some data, and lossless compression, which compresses the data without any loss of information. Major encoding standards in digital video include MPEG, Moving Picture Experts Group including MPEG-1, used in CDs, MPEG-2, used in DVDs, MPEG-4, widely used in digital media, and MPEG-H. H.264 or AVC, Advanced Video Coding. H.265 or HEVC, High Efficiency Video Coding. Major digital video file extensions include .mp4, MPEG-4 Part 14 widely used and compatible with many devices. .avi, Audio-Video Interleave introduced by Microsoft, supporting multiple streaming audio and video. .mov, developed by Apple, often used in professional video editing. .wmv, Windows Media Video developed by Microsoft for streaming applications. .mkv, Matroska Video supports unlimited video, audio, picture, or subtitle tracks in one file. Digital video refers to the method of capturing, processing, storing, and transmitting moving images in a digital format. Unlike analog video which records images as continuous signals, digital video translates these visuals into digital data, often represented in binary code, a series of zeros and ones. This transition to digital format has enabled significant advancements in video technology, offering higher quality, easier editing, and more efficient storage and distribution. Creating a digital video begins with capturing moving images with a digital camera. Light entering the camera is then converted into electrical signals by an image sensor. The electrical signals, still in analog form, are converted into digital data using an analog-to-digital converter, ADC. The ADC samples the analog signal at regular intervals and quantizing it into a digital value. Raw digital videos are usually large and thus require compression to make them more manageable for transmission and storage. Compression is of two types: lossy compression, where some data is lost to reduce file size, and lossless compression, where no data is lost, but compression rates are lower. The digital video is then encoded into a specific format or standard, such as MPEG-4, H.264, Advanced Video Coding, or H.265, High Efficiency Video Coding. These standards dictate how the video data is compressed and stored. Digital video is stored on various digital media, such as hard disk drives, solid-state drives, optical discs, like DVDs and Blu-ray discs, or flash storage, like SD cards. The encoded video can be saved in various digital formats, such as .mp4, .avi, .mov, .wmv, or .mkv. How does digital video work? The process of making a digital video involves the capturing of moving images, encoding the video, and finally storage. Digital video capture involves using a camera with a digital sensor, such as a CCD, charge-coupled device, or CMOS, complementary metal oxide semiconductor, sensor. These sensors convert incoming light into electronic signals. The analog signals produced by the sensor are converted into digital data through an analog-to-digital converter, ADC. This process involves sampling the signal at regular intervals and quantizing each sample into a digital value, resulting in a stream of digital data that represents the captured image. Digital video encoding. Due to the large size of raw digital video data, it undergoes compression to reduce file size for practical use. Compression can be lossy, which discards some data to achieve smaller file sizes, or lossless, which maintains all the original data but is less effective in reducing size. The compressed data is then encoded into a digital video format. Popular encoding standards like MPEG-4, H.264, advanced video coding, and H.265, high-efficiency video coding, dictate how video data is to be compressed and stored. These formats balance the need for quality and the necessity of reducing the file size. Storage. Unlike analog video, which is stored on magnetic tapes, digital video is stored on various digital media. This includes hard drives, optical discs, such as DVDs and Blu-ray discs, solid-state drives, SSDs, and portable flash memory cards like SD cards. The encoded digital video is saved in file formats like .mp4, .avi, .mov, or .mkv. Each format has its properties regarding compression, compatibility, and usage, allowing users to choose based on their specific needs. The process of capturing, encoding, and storing digital video differs from that of analog video in the following ways. In analog video capture, images are recorded as continuous electrical signals on media like magnetic tape without the need for conversion into digital data. Analog video doesn't undergo digital encoding or compression in the same way. Its quality can degrade over time and with copies, whereas digital video maintains its quality. Storage in analog format is bulkier and less efficient compared to the compact and versatile options available for digital video. History of digital video. The history of digital video dates back to 1969, when William S. Boyle invented the CCD, charge-coupled device, the first practical semiconductor image sensor, which became the basis of digital video. The CCD gained acclaim and became more commercialized in the late 1970s, leading to the invention of digital video. The Ampex team, who invented the first digital video recorder in 1977, is credited with inventing and popularizing digital video. The 1980s witnessed significant development in digital video formats. In 1986, Sony introduced Betacam SP, which, while not fully digital, significantly improved the quality of broadcast video with its superior analog format. This was followed by a landmark event in 1987 when Sony launched the D1 format. The D1 was the first true digital video format, recording uncompressed standard definition video and setting a new standard in the industry. The 1990s marked the era of digital video's mainstream adoption. The early part of this decade saw digital video technologies increasingly making their way into consumer markets. Pioneering companies like Panasonic, JVC, and Sony led this charge, democratizing digital video technology. A pivotal moment came in 1995 with the introduction of the DV, digital video, format. DV was a collaborative effort involving several industry giants, including Sony, Panasonic, and JVC. This format significantly impacted the consumer camcorder market, making digital video more accessible and affordable. Building on this momentum, 1996 saw the introduction of Mini DV, offering a compact form factor that enhanced the portability of digital video cameras. Entering the 2000s, high definition, HD, digital video began to take center stage. HD video offered significantly higher resolution than standard definition formats, providing clearer and more detailed images. Sony's HDCam and Panasonic's Pro HD were among the leading formats driving this high-definition revolution. These formats catered not just to professional broadcasters but also to a growing market of prosumer videographers, blending professional quality with consumer accessibility. When was video invented? First recorded video ever. The first recorded video ever was created in 1881 by the French inventor Charles-Émile Raynaud. Raynaud, a science teacher, developed a device called the praxinoscope, an improvement over the existing zoetrope, both of which created the illusion of motion by displaying a sequence of drawings or photographs in progressive phases of movement. The praxinoscope consisted of a cylinder with mirrors in the center and strips of sequential images around it. When spun, the mirrors would reflect the images, creating the illusion of motion. Raynaud took this concept further by developing the theatre optique, a larger version of the praxinoscope, which he used to project his hand-painted animated strips onto a screen, essentially creating the first animated projections. In October 1892, Raynaud publicly showcased his animated films at the Musée Grévin, a waxwork museum in Paris, marking the first public exhibition of animation. While Raynaud's work did not record live-action videos as we understand it today, his creations were foundational in the development of motion pictures and video as we know it in the current day. The first recorded digital video was achieved using Sony's D1 system. The D1, introduced by Sony in 1986, marked the beginning of the era of digital video recording in a professional broadcast environment. The D1 system was the first to record video as digital data rather than as analog signals. Unlike previous video formats, the D1 recorded uncompressed digital video, which resulted in very high-quality images without the generational loss of quality characteristic of analog formats. It captured standard definition video and was primarily used in professional broadcast studios and post-production settings. How does digital video encoding work? Digital video encoding is a process that transforms raw video footage into a digital format, making it suitable for storage, transmission, and playback on various devices. This process involves several key steps: compression, encoding algorithms, and digital storage. Raw digital video generates a massive amount of data, especially with high-resolution footage. To manage this data effectively, compression is used to reduce the file size. There are two types of compression. Lossy compression: this method reduces file size by permanently removing some of the video data, which can affect image quality. The degree of quality loss depends on the level of compression. Lossless compression: this method compresses video data without any loss of quality, but the reduction in file size is not as significant as with lossy compression. The next step involves encoding the compressed video data using specific algorithms. These algorithms determine how the video is processed and stored. Some of the popular encoding standards include MPEG, Moving Picture Experts Group. This includes various standards like MPEG-2, used for DVDs, and MPEG-4, used for online video and broadcasting. H.264, Advanced Video Coding. Known for its efficiency, it's widely used for everything from Blu-ray discs to web video. H.265, High Efficiency Video Coding. The successor to H.264 offers better compression, making it ideal for 4K and 8K video. Once the video is compressed and encoded, it is stored in a digital format. The format chosen can affect compatibility, quality, and the size of the video file. Common digital video formats include .mp4, a versatile format compatible with many devices and platforms. .avi, an older format, known for its flexibility in terms of codecs. .mov, developed by Apple, often used in professional video editing. .wmv, developed by Microsoft, primarily for Windows platforms. Encoded video must be compatible with various playback devices and transmission methods. For instance, videos intended for streaming over the internet require different considerations, like bandwidth and buffering, compared to those meant for local playback. How does video compression work? Video compression is a technique used to reduce the size of digital video files. The primary goal of compression is to make video files more manageable for storage, transmission, and playback, without significantly compromising the video's quality. The principles of video compression involve several key concepts. Data reduction techniques. Video compression works by identifying and eliminating redundant or unnecessary data. There are two main types of data reduction techniques used in video compression. Spatial compression, also known as intra-frame compression, it reduces redundancy within a single frame of video. It involves techniques like color subsampling and transforming the image data to a format where it can be more efficiently compressed. Temporal compression, also known as interframe compression, it reduces redundancy across multiple frames. This method works by only storing changes between consecutive frames instead of storing each frame in its entirety. For example, in a scene where only a small object moves, only the movement is recorded, rather than the entire frame. Lossy vs. Lossless compression. Lossy compression, this method compresses data by permanently removing some of it. It's the most common type of compression for video files because it can significantly reduce file sizes. The downside is that it can lead to a loss of quality, particularly if the video is compressed too much. Lossless compression, this method compresses data without losing any of it, so the original video can be perfectly reconstructed from the compressed data. While it doesn't reduce file sizes as much as lossy compression, it's essential for applications where preserving the original quality is crucial. Bitrate control. Bitrate refers to the amount of data processed over a given amount of time. Lowering the bitrate reduces the file size but can also decrease the video quality. Compression often involves balancing the bitrate with the desired quality. Encoding algorithms. Video compression is achieved through various encoding algorithms, with standards like MPEG and H.264 being widely used. These algorithms use complex mathematical formulas to determine the most efficient way to represent video data. Psychovisual techniques. These techniques take advantage of certain characteristics of human vision. For example, certain colors or small details might not be as noticeable to the human eye, so these can be compressed more heavily without significantly affecting the perceived video quality. What is lossy compression? Lossy compression is a data encoding method that reduces the size of a file by permanently eliminating certain information, especially redundant or less significant data. This type of compression is widely used for digital audio, images, and video, where a perfect reproduction of the original data is not necessary. The primary advantage of lossy compression is its ability to significantly reduce file sizes, which is crucial for storage efficiency and faster transmission, especially over the Internet. Some common lossy compression standards. JPEG, Joint Photographic Experts Group, widely used for digital images. JPEG compression is effective in reducing file size while maintaining a reasonable image quality. MPEG, Moving Picture Experts Group. This includes various standards used for video and audio compression, such as MPEG-1, used in CDs, MPEG-2, used in DVDs, and MPEG-4, widely used for digital media including internet streaming and broadcasting. H.264, Advanced Video Coding. A standard for video compression. H.264 is known for its high compression efficiency, making it ideal for high-definition video streaming and broadcasting. MP3, MPEG Audio Layer 3. A popular audio compression format, MP3 is used for reducing the size of audio files with a trade-off in sound quality, albeit often imperceptible to the average listener. Lossless compression is a method of data encoding that reduces the size of a file without any loss of information. Unlike lossy compression, which permanently removes some data, lossless compression allows the original data to be perfectly reconstructed from the compressed data. This type of compression is essential in applications where the preservation of the original data is crucial, such as in text documents, certain image formats, and archival purposes. Some common lossless compression standards. PNG, Portable Network Graphics. A popular image format used on the web, PNG offers lossless compression, making it ideal for detailed graphics where clarity and quality are important. FLAC, Free Lossless Audio Codec. A widely used audio format for lossless compression. FLAC reduces the file size of audio recordings without any loss of quality, making it popular among audiophiles and for archival purposes. Zip, a widely used file compression format, zip is capable of compressing various types of data, text, images, applications, etc., losslessly. It's commonly used for file storage and transmission. ALAC, Apple Lossless Audio Codec developed by Apple, ALAC is similar to FLAC, providing full lossless audio compression. It's compatible with Apple devices and software. Huffman coding, a commonly used method in lossless data compression. It's used in various file formats and compression standards, often in conjunction with other algorithms. Video encoding algorithms play a crucial role in digital video processing, enabling the efficient storage and transmission of video data. These algorithms are designed to compress video files, making them easier to store and share without consuming excessive storage space or bandwidth. The primary goal of video encoding is to compress video data to reduce its file size. Hence, video encoding algorithms mainly allow for efficient storage of videos on digital media and effective transmission, especially over the internet where bandwidth can be limited. While reducing file size, these algorithms aim to preserve as much of the original video quality as possible. The challenge lies in striking a balance between compression, smaller file size, and maintaining high video quality. Encoding algorithms are also designed to optimize video files for various playback scenarios, including streaming over the internet, broadcasting, or storage on physical media like DVDs. These algorithms utilize complex compression techniques, including both lossy and lossless compression. They identify and eliminate redundant data, and in the case of lossy compression, they also remove less significant data to achieve higher compression rates. By analyzing the differences between successive frames and the similarities within a single frame, these algorithms efficiently encode video data. For instance, in a scene where most of the background remains static, only the changes are encoded in detail. Some algorithms also adjust the bitrate according to the complexity of each portion of the video. More complex scenes receive a higher bitrate, and hence more data, while simpler scenes use less data. Some major video encoding algorithms are MPEG, Moving Picture Experts Group includes various standards such as MPEG-1, used for video CDs, MPEG-2, used for DVDs and digital TV, MPEG-4, widely used for digital media, including streaming, and MPEG-H. H.264/AVC, advanced video coding known for its high compression efficiency. H.264 is widely used for everything from Blu-ray discs to web video. H.265/HEVC, high-efficiency video coding, the successor to H.264, offering even more efficient compression, making it suitable for 4K and higher resolution videos. VP9, developed by Google, VP9 is an open and royalty-free video coding format, mainly used for streaming videos on the web, particularly by YouTube. AV1, a newer, open, and royalty-free video coding format developed by the Alliance for Open Media, designed for streaming videos over the internet with higher compression efficiency than H.264 and H.265. What are the different types of digital video coding standards? Digital video coding standards are sets of specifications or guidelines used to encode and compress digital video. They standardize how video data is compressed and converted into digital format, dictating aspects like bitrate, resolution, and compatibility with various devices and platforms. Top digital video coding standards. MPEG-2. H.264, Advanced Video Coding, AVC. H.265, High Efficiency Video Coding, HEVC. VP9. AV1. These standards vary in terms of compression efficiency, quality retention, and computational complexity, making them suitable for different applications and technologies. MOV. MOV is a multimedia container file format primarily used in Apple's QuickTime framework. It was developed by Apple Incorporated and introduced in 1991. The algorithm used in MOV video encoding is H.264 standard. One of the key improvements of the MOV format over other standards at the time of its introduction was its ability to store and synchronize multiple types of media, audio, video, text, in a single file. H.264/MPEG-4 AVC. H.264, also known as MPEG-4 AVC, Advanced Video Coding, is a widely used video compression standard developed by the ITUT Video Coding Experts Group and the ISO/IEC Moving Picture Experts Group and was first released in 2003. An advantage of H.264 over previous video coding standards include enhanced compression efficiency, the ability to provide good video quality at substantially lower bit rates, and improved flexibility in encoding video across a broad range of bandwidths and resolutions. H.265, also known as High Efficiency Video Coding, HEVC, or MPEG-H Part 2, is a video compression standard that was developed as a successor to H.264/MPEG-4 AVC. It was finalized in 2013 and developed by the Joint Collaborative Team on Video Coding, JCTVC, a collaboration between the ISO/IEC Moving Picture Experts Group, MPEG, and the ITUT Video Coding Experts Group. The improvements of H.265 over H.264 include advanced techniques like improved motion compensation for better prediction of frame content and greater flexibility in how frames are divided into blocks for encoding. MPEG-4 is a broad video coding standard developed by the Moving Picture Experts Group, MPEG, a working group of the International Organization for Standardization, ISO, and the International Electrotechnical Commission, IEC. MPEG-4 officially became an international standard in 1999. It uses advanced coding techniques like object-based encoding, allowing for separate manipulation and interaction with individual objects within a scene. Some of the improved features of MPEG-4 include its enhanced compression, flexibility, and versatility. MPEG-2, also known as H.262, is a digital video coding standard widely used in the broadcasting industry, particularly for DVDs, Super VCDs, and various television formats. It was developed by the Moving Picture Experts Group, MPEG, a collaboration of experts from the International Organization for Standardization, ISO, and the International Electrotechnical Commission, IEC. MPEG-2 was officially standardized in 1995. The MPEG-2 offers higher video quality and interlaced video support. MPEG-1 is a digital video coding standard that was primarily developed for video CD, VCD, and digital audio broadcasting. It was established by the Moving Picture Experts Group, MPEG, which is a working group under the International Organization for Standardization, ISO, and the International Electrotechnical Commission, IEC. MPEG-1 was officially standardized in 1992. The MPEG-1 standard employs a compression algorithm that uses discrete cosine transform, DCT, for reducing spatial redundancy within frames. Theora is an open-source video compression format, part of the XIF.org Foundation's free and open media projects. It was officially released in 2004. Theora is derived from the VP3 codec, which was originally developed by On2 Technologies. The Theora codec uses a discrete cosine transform, DCT, based video compression algorithm, similar to the methods used in formats like MPEG and VP8. It is used for Wikipedia projects mainly because of its accessibility. Theora is notable for being open source and adaptable. H.263 is a video compression standard originally designed for low bitrate communication. It was developed by the ITUT Video Coding Experts Group, VCEG, and first released in 1996. The algorithm used in H.263 is based on discrete cosine transform, DCT, compression techniques. H.263's standout features include enhanced compression, flexibility, and error resilience. H.261 is one of the earlier video compression standards, specifically designed for video conferencing and video telephony over ISDN, Integrated Services Digital Network, lines. It was developed by the ITUT Video Coding Experts Group, VCEG, and was first standardized in 1990. The algorithm used in H.261 is based on discrete cosine transform, DCT, and motion compensation. One key advantage of H.261 was that H.261 supported both CIF, Common Intermediate Format, and QCIF, Quarter CIF, resolutions, accommodating different levels of video quality and network bandwidth conditions. CCIR 601, now known as ITURBT.601, is a standard for digital video broadcasting, particularly in studio environments. It was developed by the International Radio Consultative Committee, CCIR, which is now part of the International Telecommunication Union, ITU. The standard was first introduced in 1982. The standard defined a resolution of 720 x 486 pixels for NTSC and 720 x 576 pixels for PAL/SECOM, with an aspect ratio of 4:3. CCIR 601 also established standards for digitizing analog video signals, specifying 4:2:2 chroma subsampling. VC2, also known as Dirac Pro, is a digital video compression format developed by the BBC, British Broadcasting Corporation. It was officially released in 2008. The core algorithm of VC2/Dirac Pro is based on wavelet compression, differing from the more commonly used discrete cosine transform, DCT, based codecs like H.264. VC2 offers flexibility, open source, and high-quality compression. H.120 was an early video compression standard for video conferencing and telephony. It was developed by the International Telecommunication Union, ITU, in the late 1970s and officially standardized in 1984. The algorithm used in H.120 was the differential pulse code modulation, DPCM, for compression, a technique that encodes the difference between successive samples rather than the absolute values. What are the different types of digital video file formats? Digital video file formats are containers that store digital video data, often including audio, subtitles, and other metadata. These formats not only encapsulate the encoded video and audio streams but also define how this data is stored and structured within the file. File formats differ from coding standards in that while the latter deals with the technical details of video compression and encoding, file formats concern themselves with the organization and storage of this data. A single file format can support multiple coding standards, offering flexibility in terms of how video data is compressed and utilized. Some popular digital video file formats are OGG Video, .ogg, Video, with file extensions .ogg and .ogv, is a free, open container format, which is a part of the OGG Multimedia Project, which was initiated by the ZIF.org Foundation in 1993. OGG Video is primarily designed for streaming applications and is known for its effectiveness in handling video and audio data within a single file. OGG Video is mostly associated with the Theora encoding standard, which was also developed by the ZIF.org Foundation. QuickTime File Format, .mov, .qt. The QuickTime file format, with file extensions .mov and .qt, was developed by Apple Inc. It was introduced in 1991 as part of the QuickTime Multimedia Framework. The QuickTime file format is designed to store a wide range of digital media types, making it particularly suitable for video editing and content creation. One of the most common video codecs used in QuickTime is the H.264, MPEG-4 AVC, standard, known for its high compression efficiency and quality. AVI, the audio-video interleave, AVI, format, with the file extension .avi, was introduced by Microsoft in November 1992. AVI is a container format designed to hold both audio and video data in a single file, allowing synchronous audio with video playback. It's meant for a broad range of video content, from standard quality video on PCs to high quality movies. One of the distinctive features of AVI is its flexibility regarding the video and audio codecs it can contain. It doesn't rely on a single encoding standard, instead, it can use a wide range of codecs. MPEG-4 Part 14, MP4, .MP4, .M4P, with DRM, .M4V. MPEG-4 Part 14, commonly known as MP4, is a digital multimedia container format. It was developed by the Moving Picture Experts Group, MPEG, and was officially introduced as a standard in 2003. MP4 is designed to store video, audio, and other data such as subtitles and still images. It's particularly well suited for streaming over the internet due to its high compression efficiency and compatibility with various devices and platforms. The format typically uses the MPEG-4 encoding standard for video and advanced audio coding, AAC, for audio. See full guide on MP4 video. Matroska.mkv. Matroska, commonly known by its file extension .mkv, is a flexible and open standard multimedia container format. It was first released in 2002 and was developed by a group of software developers led by Steve Loam. Matroska is designed to hold an unlimited number of video, audio, picture, or subtitle tracks in one file, making it ideal for storing movies, TV shows, and other multimedia content. Commonly used video codecs in MKV files include H.264, H.265, and VP9, while audio codecs like AAC, DTs, and Dolby Digital are also often used. Flash video, FLV, .FLV. F4V. F4P. F4A. F4B. Flash video, commonly known by its file extension .FLV, is a container file format used to deliver digital video content over the internet using Adobe Flash Player. FLV was introduced by Macromedia, which was later acquired by Adobe Systems, in 2002. The typical encoding standards used in FLV files include Sorensen Spark, H.263, for early versions, and later, VP6, and H.264 video codecs. MPEG Transport Stream, .MTS, .M2TS, .TS. MPEG Transport Stream was developed by the Moving Picture Experts Group, MPEG, and was first published in 1995. MPEG Transport Stream is designed for broadcasting applications, particularly for transmitting video and audio data where robustness and error correction are critical, such as in terrestrial, cable, and satellite television broadcasting. The format is also used for storing high-definition video on Blu-ray discs and DVDs. MPEG Transport Stream supports various encoding standards, including MPEG-2 and H.264 video codecs. WEBM. WEBM is an open, royalty-free media file format designed for the web. It was first announced by Google in 2010. WEBM is specifically designed for use in web browsers as part of the HTML5 video standard. Its main purpose is to deliver high-quality video streaming over the internet. The video codec used in WEBM is VP8 or VP9. GIF. GIF. The graphics interchange format, GIF, was invented in 1987 by a team at the American online service provider CompuServe, led by computer scientist Steve Wilhite. GIF is primarily meant for simple animations and low-resolution video clips on the web. The encoding standard used in GIF is LZW, Lempel-Ziv-Welch, compression, a lossless data compression technique that reduces the file size without degrading the visual quality of the image. Material Exchange Format, MXF. MXF. The Material Exchange Format, MXF, is a container format developed by the Society of Motion Picture and Television Engineers, SMPT, and was first published as a standard in 2004. MXF is intended for use in the professional digital video production, editing, and broadcasting industry. MXF is a flexible format that supports a range of encoding standards. Windows Media Video, WMV. Windows Media Video, WMV, is a series of video codecs and corresponding video coding formats developed by Microsoft and introduced in 1999 as part of the Windows Media Framework. WMV is primarily intended for streaming applications on the Windows operating system. The encoding standard used in WMV is based on the Microsoft Advanced Systems Format, ASF. MPEG-2, video, .mpg, .mpeg, .m2v. MPEG-2 is a standard for the generic coding of moving pictures and associated audio information. It was developed by the Moving Picture Experts Group, MPEG, and was officially standardized in 1995. MPEG-2 is primarily designed for encoding digital television signals and DVDs. The encoding standard used in MPEG-2 video is based on lossy compression techniques that include interframe compression for reducing temporal redundancy and intraframe compression for reducing spatial redundancy. MPEG-1, .mpg, .mp2, .mpeg, .mpe, .mpv. MPEG-1 is a standard for lossy compression of video and audio, developed by the Moving Picture Experts Group, MPEG, and established as a standard in 1992. MPEG-1 was primarily intended for video playback at a resolution similar to that of VHS, and it was widely used for video CDs, VCDs. MPEG-1's video compression is based on lossy techniques, notably using discrete cosine transform, DCT, for reducing spatial redundancy and motion compensation to minimize temporal redundancy. F4V, .FLV. The F4V file format is a variation of the original Flash Video, FLV, format, introduced by Adobe Systems. F4V was developed as part of the Adobe Flash technology and was first introduced around 2007 with the release of Adobe Flash Player 9 Update 3. F4V is intended for streaming video content over the Internet, primarily for use within the Adobe Flash Player framework. The encoding standard used in F4V files is based on the H.264 video codec. VOB. VOB. The VOB, video object, file format is a container format used in DVD video media. VOB was introduced in 1996, along with the DVD standard. VOB files are intended for storing the video, audio, subtitles, menus, and navigation contents of DVDs. VOB files typically use the MPEG-2 video encoding standard, which was the industry standard for DVD video compression. M4V. M4V. The M4V file format is a video container format developed by Apple Incorporated in 2003. M4V is primarily intended for video content distributed through Apple's iTunes Store. It is used to store TV shows, movies, and music videos that can be downloaded from iTunes and played on Apple devices like iPhones, iPads, and iPods. The encoding standard used in M4V files is H.264 for video and AAC for audio. 3GPP2, .3G2. The 3GPP2 file format, with the extension .3G2, is a multimedia container format developed by the third generation partnership Project 2, 3GPP2, in January 2004. The 3GPP2 format is specifically designed for use on 3G mobile phones. It is a simplified version of the MPEG-4 Part 14 container format, MP4, and is tailored for mobile environments with limited bandwidth and storage capacity. For video encoding, the .3G2 format typically uses the H.263 or MPEG-4 Part 2 standards. Advanced Systems Format, ASF. ASF. Advanced Systems Format, ASF, is a digital audio/video container format developed by Microsoft in 1996. It is particularly well suited for streaming applications over networks like the Internet. ASF files are commonly associated with Windows Media Audio, WMA, and Windows Media Video, WMV, codecs. Real Media, RM. Real Media, RM, is a multimedia container format developed by Real Networks. It was first introduced in 1997 as part of the Real System Multimedia Suite. The RM format is primarily intended for streaming media content on the web. It was developed to facilitate the delivery and playback of digital media over low-bandwidth internet connections, which were common in the late 1990s and early 2000s. The encoding standard used in the RM format is Real Video, which is Real Network's proprietary video codec. Real Media Variable Bitrate, RMVB, .RMVB Real Media Variable Bitrate, RMVB, is an extension of the Real Media Multimedia Container format developed by Real Networks in 2003. RMVB is specifically designed for storing multimedia content, particularly video, with a variable bitrate, which allows for a more efficient use of bandwidth and storage. The encoding standard used in RMVB is a variant of the Real Video codec. VivoActive, Viv, .viv VivoActive, using the file extension .viv, was a video format developed by Vivo Software in 1995. VivoActive was specifically designed for streaming video content over the Internet. The encoding standard used in VivoActive files was Vivo's proprietary video and audio codecs. RAW video format, .yuv The RAW video format, typically represented by the .yuv file extension, is not associated with a specific invention date or inventor, as it is more of a general format representing raw video data. It is commonly used in video editing and post-production processes, as well as in research and development in the field of video compression and processing. Unlike typical video formats that use compression algorithms, YUV files store raw, uncompressed video data. Video alternative to GIF. .giv The .giv extension is not a traditional file format but rather a naming convention introduced by the image hosting website Imager in 2014. The .giv extension typically denotes a video file that has been converted from a GIF into a more efficient video format, like MP4 or WEBM. The encoding standards used in .giv files depend on the underlying video format. For example, if a .giv file is essentially an MP4, it might use the H.264 video codec, while a WEBM-based .giv would use the VP8 or VP9 codec. AMV video format, .amv The AMV video format, denoted by the file extension .amv, was developed in 2003. AMV is intended for low-resolution video playback on portable media players, such as MP4 players and S1 MP3 players with video playback. The encoding standard used in the AMV format is a modified version of the AVI video format. DIRAC, .drc DIRAC is a video compression format and codec developed by the BBC, British Broadcasting Corporation, and first released in 2004. DIRAC is intended for use in a wide range of applications, from web streaming to high-definition television broadcasting. The encoding standard used in DIRAC is based on wavelet compression technology. Multiple Image Network Graphics, .mng was created by members of the PNG Development Group. The development of MNG began in 1996, with its specification finalized in 2001. MNG is intended for use with complex animated graphics and is seen as a more powerful alternative to the GIF format, especially for animations that require higher quality, transparency, or more colors than GIFs can provide. The encoding standard used in MNG files is closely related to that of PNG, utilizing lossless data compression techniques. Nullsoft Streaming Video, NSV, .NSV Nullsoft Streaming Video, NSV, is a media container format developed by Nullsoft in 2003. NSV was primarily designed for streaming video broadcasts over the Internet. For video, NSV typically uses VP3 or VP6 video codecs, and for audio, it often uses MP3 or AAC. ROQ, ROQ is a video file format that was developed by Graham Devine, a programmer at ID Software, for a game called The 11th Hour in 1995. ROQ was designed primarily for video game cutscenes and animations. The encoding standard used in ROQ files is a proprietary video codec developed by ID Software. SVI.SVI with the file extension .SVI, is a video file format developed by Samsung Electronics in 2005. The SVI format is intended primarily for video playback on Samsung devices. The encoding standard used in SVI files is typically a variant of the MPEG-4 or H.264 video codecs, along with AAC for audio. What is a video codec? A video codec is a software, firmware, or hardware implementation that can encode or decode data in a specific video coding format to or from uncompressed video. This is distinct from a video coding format itself, which is a specification describing how video data should be compressed and structured. A video coding format is like a set of specifications, while a codec is a tool or a set of tools used to execute the specifications. For example, H.264 is a video coding format, the specification, and OpenH.264 is a codec, a specific implementation, that encodes and decodes video according to the H.264 format. This means that for any given video coding format, such as H.264, there could be multiple codecs available that implement the specifications laid out by that format, each possibly offering different features or optimizations. What does digital mean in movies? In the context of movies, digital refers to the method of capturing, processing, storing, and distributing film content using digital technology, as opposed to traditional analog methods like 35mm film stock. Digital cameras are used to capture motion pictures as digital video, rather than recording them on film. Digital filmmaking allows for immediate playback and editing, more flexible shooting options, and can often be more cost-effective than shooting on film. Additionally, editing, color grading, adding visual effects, and sound design in digital movies are done using computer software. This allows for a more efficient and versatile post-production process compared to analog editing methods. Movies can also be distributed digitally via the internet, on physical media like Blu-ray discs, or through digital copies. In cinemas, digital projection has largely replaced traditional film projectors. Digital distribution and projection provide higher consistency in picture quality and ease of handling and transportation. Digital movies are stored in various digital file formats and can be archived on servers, hard drives, or cloud storage, offering more efficient and long-lasting storage solutions compared to film reels. Despite the differences, digital and analog video editing share a core similarity. Both are creative processes focused on assembling and manipulating video footage to tell a story or convey a message. Regardless of the medium, video editing requires a blend of technical skill and artistic vision to select, sequence, and enhance footage in a way that fulfills the creative intent of the project. This fundamental aspect of storytelling through video remains consistent, whether achieved through the physical splicing of analog tapes or the software-based manipulation of digital files. Thank you for watching this video.